polynomial operations. Today we're going to look at that I can multiply polynomial expressions. So go ahead and put your name in that top right hand corner and today's date. Last time we looked at adding and subtracting polynomials. Today we're going to look at multiplying polynomials. Now our first term we're going to look at today is our distributive property. So distributive property is when we multiply a term beside a parenthesis to all terms inside parentheses. Now, because we are multiplying, we have to remember our rules for multiplying monomials. So we're going to multiply the coefficients and add the exponents. Now our next term here is FOIL. So FOIL is when we multiply, let me backtrack and say it is a way to multiply two binomials. And we spoke about that in the last video, that binomials are like bicycles. Bicycles have two wheels, so binomials have two terms. So it is a way to multiply two binomials together. And FOIL is just a way FOIL is just a way to help us remember it, because it's actually just a way to distribute. FOIL just helps us have a way to remember how to distribute. I always tell people you can FOIL if that helps you, and we're going to review it right now. But if you don't like to FOIL, just remember it's just the distributive property. That's all it's going to do. So FOIL stands for the pattern we're going to use to multiply two binomials together. So I'm going to write out to the side here. So if we have x plus 2 times x plus 3. So the F in FOIL stands for the first terms. Oh, not fist, first. There we go. First terms of each parenthesis. So first in each parenthesis, I have x times x. Now the O stands for the outer terms, so your outermost. There you go, outermost terms. I always tell people, like, if you think about a full problem being like a donut, your outside terms would be like those on the outside of a donut. So that would be our x times 3, so it's positive x times positive 3. Alright, the I stands for the innermost terms. So once again, if you think about like the donut on the inside, that would be your 2 times x. So positive 2 times a positive x. And then the L stands for your last terms in each parenthesis. So 2 is the last term in this parenthesis times 3 is the last term in that parenthesis. So positive 2 times positive 3. And then you just go through there and you multiply it. So x times x is actually x to the first times x to the first. So you add those exponents. 1 and 1 makes 2. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. Last step we have to do is combine like terms. Combine like terms. So we're going to say x squared has no friend, so he drops down. My plus 3x goes with my plus 2x to give us plus 5x. Then we drop down our plus 6. Because remember, when we combine like terms at this step, we do not change the exponents. We just say, hey, I'm an x, I go with the other x. So example 1. We're given 8x squared times 5x squared plus 5x minus 5. Now this is just a good old-fashioned distributive property because we just have one term on the outside of the parenthesis. that we're going to multiply to all terms inside the parenthesis. For this first one, I'm going to show it the long way, and then we'll kind of skip some steps when we do the second example. So we do 8x squared times 5x squared. And now he's a positive 8x, so I have to use a plus sign, so positive 8x squared times a positive 5x. And now a positive 8x squared times a negative 5. Now pretend each and every single one of these is an individual monomial problem. So focus just on this, 8x squared times 5x squared. So first things we're going to do is multiply our coefficients. So 8 times 5 is 40. And now we're going to add the exponents of our x. So I have x, and then 2 plus 2 gives me x to the 4th. And just keep going. So now I'm going to have 8x squared times 5x. So positive 8 times positive 5 is positive 40. I have x squared and just an x here. If you remember, just an x is x to the first, so we do 2 plus 1 and get x to the third. And now for our last one. 8x squared times negative 5. So 8 times negative 5 is negative 40. Because he has the x squared, he just drops down because there's nobody to go with. Now we check it for like terms. So I have an x to the 4th, an x to the 3rd, an x squared. So since they're all different, that's as far as we can go. If you also notice our answers in descending order, like we talked about last time, we have 4, 3, 2 with the highest exponents to lowest. And we're good. Let's see our second example, 2. We got 4r to the 3rd times 3r squared minus 7r minus 6. So once again, it's distributive property because we have one term on the outside being multiplied to a whole parenthesis, a whole polynomial. So now, we just are going to multiply. And this time we're going to skip steps. We're going to say 4r to the 3rd times 3r squared. So we're going to multiply our coefficients. 4 times 3 is 12. And add our exponents. 3 plus 2 is r to the 5th. 4r cubed times a negative 7r is 4 times negative 7, which is negative 28. R to the 3rd. Remember, this is just an r, which means it has a hidden 1, so we do 3 plus 1 and get r to the 4th. Now lastly, we do 4r cubed times a negative 6. So 4 times negative 6 is negative 24. R cubed stays with it because he has nobody over here to go with. And we're all good. That's our final answer. We have 12r to the 5th minus 28r to the 4th minus 24r cubed. Alright, let's see our next set of examples. So example 3 here. If you notice, this time we have two terms in each parenthesis. We have 5k plus 3. That's two terms. 5k is 1, 3 is 1, times k minus 2, which is two terms, k and our 2. So since it's a binomial, two terms times a binomial, two terms, that means we're going to have to FOIL. Remember, FOIL is just a way to help us how to remember to distribute. So, I'm going to distribute my 5k first and do 5k times k. So 5k times 1k means 5 times 1 is 5. And then k to the first and k to the first, we add those together, so 1 plus 1 gives us k squared. So check F. Now outside is still my 5k times my negative 2. So 5 times negative 2 is going to be negative 10, and my k stays with it. So 5k times negative 2 is negative 10k. And if you notice, all we did for the F and the O is just distribute my 5k. Now when we move on to the I for inside, it's going to move us on to our next term of 3. So we're going to do 3 times k and get a positive 3k. Check, and now our last. So the last terms of each parenthesis, which is still distributing our 3 here. So 3 times negative 2 is negative 6. There we go. Now since we have successfully FOILed, now we're going to combine our like terms. 5k squared drops down because I don't have any other k squares to go with it. My middle portion here gets combined because they both have k's. I have a negative 10k plus 3k, which is going to give me negative 7k, and drop down my minus 6. Remember, when we add or subtract like terms, we do not change the variable. So now that I have k squared and just a k and then no k, it's in descending order and I have no like terms. That's as far as we can go. That's our final answer. So if you notice, this first part of our FOIL just distributes our first term to the second parenthesis. And this second part, I and L, is distributing our second term to our parenthesis. So FOIL is just a way to help us to remember how to distribute. Whatever helps you the most, stick with it. Example 4. We have 3n plus 1 times 7n minus 8. So once again, we're going to FOIL. So first terms in each, so F. 3n times 7n. So 3 times 7 is 21. N and n make 1 and 1 makes 2, so it'll be n squared. Now the outside is still distributing that first term, so 3n times negative 8. 3 times negative 8 is negative 24, and we keep the n with it. So 3n times negative 8 is negative 24n. Now we move on to the inside. So that distributes now our 1. So 1 times 7n is going to be positive 7n. Because 1 times 7 is 7, keep the n with it. And our last term is 1 and negative 8. So 1 times negative 8 is going to be negative 8. And now we combine our like terms. So my 21n squared has no friends to go with, so he drops down. We combine my negative 24n plus 7n and get a negative 17n and drop down our minus 8. Once again, that's as far as we can go. There are no like terms, so that's our final answer. As far as it goes, guys, one of the big things about FOILing is that these terms right here, the middle two, get combined because they're the like terms there. So that's a good little rule of thumb to watch out for combining like terms on FOIL problems. Those middle two should be yours that have the same variables with them.